Question number 38, plus then diagonal identity, R.D.sharma chapter 11. Proof. Under root 1 plus sin a upon 1 minus sin a is equal to sec a plus tan a. Left hand side, it is written under root 1 plus sin a and upon 1 minus sin a. We can simply prove by first taking its rationalized by the opposite of denominator, like 1 plus sin a, 1 plus sin a, so that it becomes 1 plus sin a whole square, and this become 1 minus sin square. Further we can write 1 plus sin 1 plus sin a, 1 plus sin a upon cos square a, and this become 1 plus sin a upon cos a. We can write again 1 plus cos a plus sin a upon cos a. 1 upon cos a we can write sec a, and plus sin a upon cos a we can write tan a. Is equal to right hand side. And question number 39, it is asked to prove under root 1 minus cos a upon 1 plus cos a plus under root 1 plus cos a upon 1 minus cos a is equal to 2 cos a. So we should first take the left hand side, in which 1 minus cos a and 1 plus cos a. We should rationalize it first by multiply it to opposite of its denominator, like 1 minus cos a and 1 minus cos a, both it two sides, and 1 plus cos a upon 1 minus cos a. We can simply rationalize it by multiplying opposite of its denominator, so that here we get 1 minus cos a whole square, and here 1 minus cos square a. Here we get 1 plus cos a whole square and 1 minus cos square a. Here we get 1 minus cos a upon 1 minus cos a. It become 1 minus cos square become right sin square a, and 1 plus, after opening uh, square root, we get 1 plus cos a, and in place of we can write 1 minus sin square a, sin square a under root. So we get here 1 minus cos a and sin a, again 1 plus cos a and sin a. Because their denominator is same, we can write sin a and 1 minus cos a plus 1 plus cos a. So cos a divided by cos a, we get here 2 upon sin a. So we know that 1 upon sin a means 2, 1 upon sin a means cosec a. So we can write it 2 cosec a, which is equal to right hand side. In question number 40, it is asked under root sec theta minus 1 upon sec theta plus 1 plus under root sec theta plus 1 upon sec theta minus 1 is equal to 2 cosec theta. So if we change sec theta, so we can write here 1 upon cos theta minus 1 upon 1 minus cos theta plus 1, and plus again we can write 1 upon cos theta plus 1 upon cos theta minus 1. So if we take the LCM, what we find? We find here cos theta 1 minus cos theta upon 1 plus cos theta plus same like that 1 plus cos theta upon 1 minus cos theta. So cos divided by cos theta, cos divided by cos theta, we get here 1 minus cos theta upon 1 plus cos theta and plus 1 plus cos theta upon 1 minus cos theta. So if we rationalize it by multiplying opposite of denominator, so we can write 1 minus cos theta and 1 minus cos theta plus 1 plus cos theta upon 1 minus cos theta into 1 plus cos theta 1 plus cos theta. We get here 1 minus from 1 minus cos theta का whole square, and this will become 1 minus cos square theta plus this become 1 plus cos theta का whole square, and this become 1 minus cos theta. After that this become 1 minus cos theta whole square, this become sin square theta, and this become 1 plus cos theta whole square, and this become sin square theta. After that this become 1 minus cos theta by sin theta, and this become 1 plus cos theta by sin theta. 1 minus cos theta sin theta. Now this become, after that this becomes sin theta, and this 1 minus cos theta plus 1 plus cos theta. So cos theta divided by cos theta, and here 2 upon sin theta. We can write 2 upon theta, 2 upon 1 by sin theta is equal to 2 cos theta is equal to right hand. In question number 41, under root 1 plus sin theta upon 1 minus sin theta plus 1 under root 1 minus sin theta upon 1 plus sin theta is equal to 2 sec theta. So we should to take first left hand side, which is 1 plus sin theta under root and 1 minus sin theta, and multiply it root of opposite of denominator, which is 1 minus sin theta, this also, and then 1 minus under root 1 minus sin theta upon 1 plus sin theta multiplied by opposite root of denominator, means 1 minus sin theta and 1 minus sin theta, so that it become 1 plus sin theta whole square under root, and this become 1 minus sin square theta, and this become 1 minus sin theta whole square, and this become 1 minus sin square theta. After removing root, this become 1 plus sin theta, and this become cos square theta, cos theta. We can also write this one time more, same like that, and this 1 minus sin theta by cos theta whole square, or you can also use cos square theta and cos square theta, cos square theta and cos square theta, and this become, after removing root, 1 plus sin theta and cos theta, and this become 1 minus sin theta upon cos theta. And if you take LCM, it becomes cos theta 1 plus sin theta plus 1 minus sin theta divided by sin theta. This becomes 2 upon cos theta, and this becomes 2 1 by cos theta, and 2 1 by cos theta means 2 sec theta, which is equal to right hand side. This question number 42. It is under root 1 plus cos theta upon 1 minus cos theta plus under root 1 minus cos theta upon 1 plus cos theta equal to 2 cosec theta. So we first take left hand side, which is 1 plus cos theta upon 1 minus cos theta, and we should multiply it by the opposite denominator of opposite denominator of root, which is 1 plus cos theta and 1 plus cos theta, and this 1 minus cos theta under root and 1 plus cos theta into 1 minus cos theta and 1 minus cos theta. So this become 1 plus cos theta whole square minus 1 minus cos square theta, and this become 1 minus cos theta whole square and 1 minus cos square theta again. So next step, it is 1 plus cos theta whole square by this become sin square theta, and this become 1 minus cos theta whole square, and this become sin square theta. After removing root, this become 1 plus cos theta, and this become sin theta. This become 1 minus cos theta, this becomes sin theta. If you take LCM, so it is sin theta, and this become 1 plus cos theta, and this become 1 minus cos theta. So cos theta divided by cos theta, so this becomes 2 upon sin theta, which is 2 into 1 by sin theta, is equal to 1 by sin theta means cosec theta. So we can write here 2 cosec theta, which is equal to right hand side. In question number 43, it is sec theta minus 1 upon sec theta plus 1 is equal to sin theta upon 1 plus cos theta whole square. So left hand side, it is sec theta minus 1 and sec theta plus 1. We can write it 1 upon cos theta minus 1 upon 1 upon cos theta plus 1. If we take LCM of it, we get here what? Cos theta 1 minus cos theta and here again cos theta and 1 plus cos theta. Cos theta divided by cos theta, we get here 1 minus cos theta upon 1 plus cos theta. You can write here 1 cos minus cos theta upon 1 plus cos theta and multiply it 1 plus cos theta into 1 plus cos theta, so that it become 1 minus cos square theta, and this become 1 plus cos theta whole square. So you can add it sin square theta and 1 plus cos theta whole square, and also we can add it sin theta by 1 plus cos theta whole square, which is equal to 5. In question number 44, it is in brackets sec theta minus tan theta whole square is equal to 1 minus sin theta upon 1 plus sin theta. First we take left hand side to prove it. Sec theta, we can write sec theta as 1 upon cos theta, and tan theta sin theta into cos theta of whole square. If we take LCM of it, we get here cos theta and 1 minus sin theta whole square. We can also write it 1 minus sin theta whole square. 1 minus sin theta whole square means 1 minus sin theta and 1 minus sin theta 2 times means cos square theta मतलब 1 minus sin square theta, so that we can write 1 minus sin theta, 1 minus sin theta and 1 minus sin theta and 1 plus cos 1 minus plus sin theta. 1 minus means this become 1 minus sin theta upon 1 plus sin theta, which is equal to right hand side. In question number 45, 1 minus cos a upon 1 plus cos a is equal to cot a minus cos a का whole square. We can write left hand side as 1 minus cos a and 1 plus cos a, and multiply it to opposite of the denominator like 1 minus cos a upon 1 minus cos a. So this become 1 minus cos a whole square, and this become 1 minus cos square a. We can further write it 1 minus cos a whole square, and this becomes sin square a. We can further write it 1 minus cos a upon sin a whole square, and also write it 1 upon sin a minus cos a upon sin a. 1 upon sin a means this becomes cos a, and cos upon sin a means cot a whole square, because their tendency is reversed, so we can change according to answer. If we take minus 1 common, so this can interchange. We can write here cot a minus cosec a whole square, and after removing the bracket, minus 1 whole square become 1, so it become cot a minus cosec a whole square, which is equal to right hand side. In question number 46, it is 1 upon sec a minus 1 plus 1 upon sec a plus 1 is equal to 2 cosec a minus cot a. So first we take left hand side by taking its LCM. This will sec a minus 1 sec a plus 1 sec a. Sec a divided by sec a minus 1 divided by this. So this go outside, and sec a plus 1 divided by sec a plus 1. We can write here sec a minus 1. After that, 1 divided by 1 becomes 2 sec a, and this becomes sec square a minus 1. This is equal to, and we can write sec a 2 upon 1 upon cos a, 1 upon cos a, cos a, and sec square a minus 1 is equal to tan square a, and further tan square a written as 2 upon 1 upon cos a and sin square a upon cos square a. This can be, this go to upside, this become 2 into cos a into cos a, and this become cos a into sin a into sin a. Cos a divided by cos a, so this is remaining 2 cos a upon sin a into sin a. We can write 2 upon sin a, 2 upon sin a, 2 upon sin a into cos a upon sin a. 2 upon sin a means 2 cosec a, and cos upon sin a means cot a. In question number 47, it is cos a upon 1 minus tan a plus sin a upon 1 minus cot a is equal to sin a plus cos a. First we take left hand side, which is cos a upon 1 minus tan a. We can write in place of tan a sin a upon cos a, and again sin a 1 minus cos a upon sin a. If you take the LCM of both side, this becomes cos a upon cos a, this becomes cos a minus sin a, and this becomes sin a upon, if you take LCM, this becomes sin a divided by 1 and to multiply by 1 gives sin a minus cos a, and this go to upside, this also go to upside, so this becomes cos square a and cos a minus sin a, and this becomes sin square a, and this becomes sin a minus cos a. Further we can write it cos square a and cos a minus sin a, because the denominator are interchange both are, so we can change its sign to take out its in numbers. It will become cos a minus sin a. If we interchange its sign, then the numbers of appearance will also change. So now if we take LCM of it will become cos A minus sin A. It will become cos square A minus sin square A. Further we can write it cos square. This is a form of A square minus B square, means A plus B and A minus B. So we can write it cos A plus sin A and cos A minus sin A by cos A minus sin A. So we divided by cos this to this. Our answer is cos A plus sin A, which is equal to right hand side. In question number 48, it is cosec A upon cosec A minus 1 plus cosec A plus 1 is equal to 2 sec square A. So if we take left hand side and take the LCM of left hand side, we write it cosec A minus 1 and cosec A plus 1. That's 1. Cosec A minus 1 divided by cosec 1 minus 1. So it becomes cosec A and cosec A plus 1. And here if divided by this, it becomes cosec A and cosec A minus 1. And if we multiply this, we get here cosec square A plus cosec A plus cosec square A minus cosec A minus cosec A divided by this, and we write here cosec square A minus 1. After that we can write 2 cosec square A upon cosec square A minus 1. Further we can write it 2 cosec square A upon cosec, in place of cosec square A minus 1 we can write cot square A. Now we can write cosec square A as 2 upon sin square A, and cot square we can write cos square A upon sin square A. This go to upside and this becomes 2 sin square A upon sin square A into cos square A. This divided by this, it becomes 2 upon cos square A. Now this can be write cos square A means sec square A. 1 upon cos square A means sec square A. So this will our right hand side.